Hello guys, my name is Yankee and in this tutorial we are going to see how we can create, deploy and test serverless function locally on our machine. So for that we will be using a tool called OpenFaas as in function as a service. So OpenFaas is a framework that is used to create serverless functions using Docker and Kubernetes. It is highly scalable and comes with auto scaling and metrics. So let's get started. So to follow along in this tutorial, we are going to be needing a bunch of tools, and the first tool we are going to install is called Arcade, and this is going to help us install other tools. So the Arcade tool is created by Alex Ellis, who is also the creator of OpenFaas, and this tool helps us to install, CLI related applications for Kubernetes, and it also allows us to install applications directly to Kubernetes cluster. So it's a pretty handy tool. If you do not have it already, you can get Arcade from the instruction on the GitHub page. So I already have Arcade installed on my machine. So if you do Arcade, then you are going to be greeted with this help message, and we are going to install a bunch of tools using this. So the first tool is going to be Arcade get kubectl. So kubectl is a command line application that allows us to communicate with Kubernetes API. So I already have it installed, but yeah, it's going to update the version. And all the binary downloaded using Arcade is stored in CD Arcade bin on your home directory. So it also gives you the instruction to like export path variable to that directory, so the binary is accessible on your terminal. So the next application we are going to install is called kind. So kind Kubernetes in Docker, that is what kind stands for, and it allows us to bootstrap a local Kubernetes cluster on our machine using Docker. So for this tutorial you also need Docker on your machine. If you do not have Docker, do install it using the official Docker page. So I have Docker installed on my machine. And the next tool we are going to install is called faas CLI. So Arcade Kit faas CLI. So faas CLI is a command line application that allows us to interact with OpenFaas services in the Kubernetes cluster. So it's a pretty handy tool to build, deploy, and run our serverless functions on Kubernetes using OpenFaas. So a few words on Arcade. So Arcade is a pretty handy tool, like I've mentioned earlier. And if you do Arcade Kit, it shows you a bunch of tools that you can easily install on your machine. So all of these tools are related to Kubernetes. So it's one-stop solution for them. Now that we have all the tools installed on our machine, like Kind, kubectl, OpenFaas, the next thing we want to do is set up a local Kubernetes cluster. And to do that, I'm going to head on to Kind's documentation and head on to local registry. So we are going to set up a local registry because to deploy application on Kubernetes, you need to package it as a Docker image and deploy it. So to do that, we are going to set up a local Docker registry. And kindly offers us this script where we can bootstrap a Kubernetes cluster and run a Docker registry at the same time. So I'm going to copy the link to this file. I'm get out to my terminal. Going to create a directory called OpenFaas, cd into it. Then I'm going to download that file. All right. So as you can see, this is a shell script. So we need to run it, make it executable. Executable. So let's see the contents of this file. So on the first few lines, you can see we are registering a Docker registry. So the name of the registry is kind registry, and it is running on localhost 5000. And to run this uh, registry, we are using this command docker run restart always port localhost 5000, and this is the command for creating a kind cluster. So it uses the command kind create cluster dash config and all the configuration related to our Docker registry. And finally, we have this config map which describes how tools should communicate with a local registry from the Kubernetes cluster. So now that we have this, and before we run this script, what we need to do is head on to our Docker desktop settings and add localhost 5000 as our insecure registries to allow HTTP communication to the uh, local registry. Else, it's going to throw an error and our application will not be deployed. So if you are using Mac or WSL2 on Windows like I am, you can go to the settings and under Docker engine, add this line. If you are on Linux or any version of Linux, variant of Linux, what you can do is head on to the Docker docs, and it contains all the information related to setting in secure registries. So basically what you have to do is go to slash slash etc slash docker slash daemon.json, I believe. So you can edit the configuration there. And once we have that setting, so I already have it here. What I'm going to do is create a kind cluster, a Kubernetes cluster, and a Docker registry. So simply kind with registry.sh, going to create a Kubernetes cluster using a Docker container. So it might take a few time here. So once this is done, our kubectl is already configured to use this Kubernetes context. So we can like do kubectl config current context, and as you can see, we are using kind context. We must have our nodes ready. So I do kubectl get nodes to get our nodes. So yeah, our control plane is not ready. It's like creating. It might take few seconds to few minutes depending on what hardware you're on. And to check if the services inside our Kubernetes cluster are running or not, we are going to use kubectl uh, get pods minus n kube system. So all the services on our Kubernetes clusters are running and we are ready to deploy our application on it. So next, I will also like to check docker logs minus f kind registry if our registry is working or not. So as you can see, our registry is up and running. So next up, we are going to install OpenFaas onto our cluster. And to do that, we are going to use the arcade tool again. So it's as simple as doing arcade install OpenFaas. So it's going to install OpenFaas. Yeah, going to take some time and boom, OpenFaas is like installed on our Kubernetes cluster. Kubectl pos minus n, so OpenFaas. As you can see, Kubernetes is creating services. I mean, like pods for our OpenFaas cluster or OpenFaas framework that supports serverless functions when we deploy to it. So it has got KubeWorker, Prometheus, NATS, Gateway, Basic Auth, and all these good things comes by built in. Let's use the watch mode key. So alert manager is running. So it might take some time. I'll return back when everything is running. So now I have all my services related to OpenFaas up and running. The next concept I would like to introduce is called templates in OpenFaas. So if you are going to create a serverless function using any languages, OpenFaas provides you with a template that you can use to bootstrap functions easier and more quicker. So to list all the templates, what I'm going to do is fast CLI template stored list. As you can see, there are a bunch of templates for different languages. So it has got one for C Sharp, Go, Java, Node, Python, even one for Rust. So this is pretty much community driven. It has got a bunch of template. Uh, you can also go to the GitHub page and see other information related to the template as well. So what version it is running on, right? So Node 14, 12, Python, and all these things. So back to my terminal. for this tutorial, I'm going to be using Python 3 dash Flask package. So I can download this package onto my local machine using faas CLI template for pool Python 3 Flask. So what this is going to do is download templates related to Python 3 dash Flask, and as you can see, there is a template directory on my OpenFaas folder. So if I do t, I don't have I will just cd into template, and you can see there are a bunch of templates related to Flask. So we got one for 2.7 and all these other things for different architecture and different uh, operating systems. So Flask Debian, SDP Debian, ARM, HF, and things like that. So the only template we are interested in is Python 3 dash Flask. We can remove all the other things here as well. 3 dash Flask, and if I go here, so here is the main function folder. So this is the function folder that is going to be created when we do faas CLI new. We are going to see it later on. So all the contents inside this folder is going to be given to us to write our function. And we also have this Docker file. So Docker file is the main component or the glue that is binding together all the components of this template. So it has got all the information, all the commands that needs to be run to build and deploy your functions. So it comes pre-packaged, so you can just focus on writing your function and do not care about anything else. Index.py file is the entry point for the Flask server we will be running. So as you can see, we have handler.handle, and we are passing the request um, to that handle function. So if you go and inside the function folder in the handler, we have the handle function, and it is getting the request passed down from this index.py file. So next we have requirements.txt and all the requirements that is required for serving this application. And template.yml is something that we are going to see later on. So that is the content of the template. So if you want to make changes, you can do so on the Docker file as well. But for the simplicity of this tutorial, I will not be touching anything here. So let me go back. So I'm going to create a new function using the Python 3 Flask template. So what I'm going to do is faas CLI new. So the project we are going to create is a simple dictionary application. Whenever we give a word to it, it is going to return a meaning on other things related to that word. So it's called pydict. And so we are going to be using Python 3 Flask Debian template, and boom, we have a folder called pydict. That is the name we have given to our function, and we have this pydict.yaml file. That is the configuration file to deploy our application. And if we go to the pydict file, you can see all the contents of the function folder we saw earlier in the templates folder. It has got handler, and if you want to write test, it has got handler test, requirements talks.ini, and so on. So next, I'm going to be creating my function. Get a step back, and I'm going to open VS Code on this directory. So there are a bunch of things open. I'm going to close everything. The only thing I care about is the pydict, directory where my function is going to rest. So for this project, we are going to need a package called pydictionary. So this is all we are going to need. And in the handler function, what I'm going to do is to the top from py o and ari dictionary import by oh wait, so it's both. So once I have this imported, what I'm going to do is get it. So dictionary goes to py dictionary, right? So once I have that initiated, all I have to do is return dictionary dot meaning and request, so which is going to be a word in this case. So it's a pretty bare minimum function. You can go and build much bigger functions with much more complexity, but for the sake of this tutorial I'm going to create it pretty simple, and we have our function ready. Now next what I'm going to do is head on to pydict.yaml file. So to explain about this file, it is using the version 1. You can think of this as a manifest file, kind of like Kubernetes, but it talks with faas CLI. So yeah, the provider is OpenFaas. Gateway is localhost 8080. So gateway is the URL where we are going to send our request to for functions. So this endpoint is going to respond to our call to the functions. And to see this, I'm going to go to my CLI, and I do etl git pods, uh, it's services pods in this case. So you can see the gateway service, and it is running on port 8080, and later on we are going to port forward it to our localhost port 8080 and communicate to this gateway API. But for now, let's get back to the YAML file. Next, we have a section called functions. So this is going to hold, information related to our functions. So for now, we just have a single function called pydict, but later on we might have multiple functions here. And in pydict, we have this, field called lang, which points to what kind of template we are using. So we are using Python 3 Flask Debian. If I go to my template, so there is Python 3 Flask Debian, and another one is handler. So handler means where our function resides. Currently it resides on dot slash pydict, meaning it's in the current directory inside of the pydict folder. And the name of the image, for the name of the image, we have to put a fully qualified docker image name. And in our case, since we are running docker registry locally, we need to add localhost 5000 as a suffix here, else it's not going to work. Let's head on to my terminal, and what I'm going to do is faas CLI build -f pydict.yaml. So it is going to create a docker image out of the configuration mentioned in pydict.yaml. It might take some time, all dependencies and run all the commands that are inside of this docker file. Yep, so we have our image ready, and if I go to my code editor, it's going to create a file called a folder called build, and inside of there we have a pydict of our function, and it is going to replace everything inside of this as the content of pydict. So inside of the function we have our pydict function that we just created, and all the other things that are here are copied here. So that's how it works. Next up, we are going to see the image. So docker images, and we can see we have localhost 5000 pydict, and it was created 43 seconds ago, and the size of a function is 355 MB. So for a fairly small image, for a fairly small application, it's a huge image. And to optimize it, like I've said earlier, you can dive into the template directory and onto Docker file. You can change a bunch of stuffs to make it even smaller. So maybe use Alpine image, something like that. So go knock yourself out on this one. And now we have our image ready. Next thing we need to do is push it to the Docker registry. So to do that, I'm going to do faas CLI push -f pydict.yaml. So again, it's going to read the configuration there, and it's going to look at the image section here, finds this and pushes this image to the local Docker registry. If I go here, docker logs -f, So yeah, like pushing images here. Not essential to see right now, but anyway, yeah, our image is pushed. Now, next thing we need to do is we have our image built, we pushed it to the Docker registry. Now we need to deploy it to the Kubernetes cluster. And before we do that, there are a bunch of things that we need to configure. It's a small configuration, but yeah, bear with me. So the next step is to port forward um, OpenFaas gateway service to our local host. We need to do this because in order to communicate with the OpenFaas service, we need an outlet. So since we are not running on managed cloud, we do not have a public URL that we can, run our commands against. So for this, we are going to port forward. So again, kubectl get service OpenFaas. So if you were running on, managed cloud, you will be uh, using the AP external IP of external gateway external. But for this, we are going to port forward the gateway service. And to do that, what I'm going to do is kubectl port forward -n. So the namespace is OpenFaas and service gateway to our localhost 80. So we are port forwarding to localhost 8080. I'm going to just jump into a different terminal now and leave that port open and running. Uh, Back to my browser. So since we have like port forwarded it, let's go and do look 8080. Now it is like prompting us to input our username and password. So the gateway is uh, authenticated, so we need access to this. But where are we going to find it? So when we were like installing OpenFaas onto our Kubernetes cluster, it has also deployed secrets to OpenFaas. So we are going to get secret, which is going to be our password, and the username is going to be admin in this. So back to the terminal again, and we are going to see the secret in action. So kubectl get secret -n OpenFaas basic auth -o as station. So this is the secret that is inside our OpenFaas namespace. So as you can see, the password that we are looking for is inside data and basic auth password. And this is base64 encrypted. We need to get this value and decrypt it using base64. So it's pretty straightforward. Uh, so while I'm like decrypting this password, I'm going to store it in a environment variable called password. So it's going to be password, and I already have this command here. So I'm evaluating, this command and storing it to the password variable. What I'm doing is kubectl getting the secret. So most of the commands are like similar to a verb, but what I'm doing extra is like passing the JSON path argument and getting the data from password from .data and basic auth passwords. It's data and basic auth password, and I'm going to pipe the output to base64 and decode the value and echo it and save it to password. So once that is done, I'm going to do echo $password, and this is going to be the password for my OpenFaas UI. Back to the browser, so password admin and boom. So this is the OpenFaas UI where I can see bunch of functions that I deploy, and I can even like trigger functions from here as well. And there is this handy thing called OpenFaas store, where you can get functions from other places and deploy it to your cluster and test it out. So it's pretty cool. You can test it yourself, but I'm not going to do this in this tutorial. So once we have the password, we also need to authenticate fast CLI to communicate to the OpenFaas service gateway because it's authenticated. So for that, what I'm going to do is echo -n password, and I'm just going to do login -s to do the trick. This is going to authenticate my fast CLI to talk with the OpenFaas gateway. So once that is done, now I can finally finally deploy my application. So it's faas CLI deploy minus f pydict.yaml and enter. So, oh, sorry, I'm in my home directory. I should be inside OpenFaas. And let me repeat that command again. Okay, it's accepted and my function is deployed. So to see the status of my function, I can go to kubectl git pods minus n openfast minus fn namespace. So it's already running. Let me go back to the browser, and as you can see, we have our function pydict here, and you can trigger it from here as well. So what I'm going to do is, write a word, brevity, and I want to know the meaning of it. So I'll just invoke it, and it's going to give me this result. Noun, the use of brief expression, the attribute of being brief or fleeting. So yeah, this is pretty cool. I mean, our function is ready to use, and we get this cool UI where we can like test this function. You can like pass around JSON, but for this function it is just text. And if you are not a UI kind of person and you want things to be done in the terminal itself, so faas CLI got you covered as well. So I'm going to do brevity again and pipe it to faas CLI invoke and the name of our function. So it's going to return the same result as before. Yep, the use of brief expression. Yep, the same thing again. So this is pretty handy. So now like that we have like authenticated faas CLI and we have everything set up, the next function you are going to deploy is going to be pretty simple. You just have to bootstrap a new template and this deploy it. And we have done 3 steps here. One is faas CLI build, another was faas CLI push, another was faas CLI deploy. All of these commands can be summarized into one called faas CLI up. So if I do help up, so this is going to bootstrap all these commands, which is going to like build, push, and deploy OpenFaas functions. So that is pretty handy as well. So now we have all of our setup ready. It only gets easier from here. So we can like create a bunch of functions and just deploy it. And I'm feeling a bit adventurous today, so I'm going to create a new function as well so that we can see how we can handle multiple functions using OpenFaas. So again, faas CLI new, it's going to be called Translator. So translator. So what this function is going to do is when we pass a word and the language we want it to be translated to, it's going to like send it in that language. So the language template is again Python 3 Flask Debian, and what I'm going to do here is append. So what it is going to do is append the configuration related to this new translator function onto our existing pydict.yaml. Else it is going to create a separate YAML file called translator.yaml, which I do not want because everything can be handled on a single YAML file. So once we do that, okay, mistake there. So once we do that, we are going to have another directory called translator. So again, let me go back to my code editor, go inside translator. So again, the same template. Again, you can go inside the handler function and just write your code there. So for this function as well, we are going to have a single dependency. It's going to be a package called Google Trans, and I'm going to pin the version as 4.0.0 minus RC1. And next I'm going to go to my handler function again. So I'm going to dependencies that is required here. So from trans translator and from flask port JSONify, because we want to send out a JSON response to the user later on. So import JSON as well, handle JSON. All right. Next, what I'm going to do is this is going to be a JSON request in this case. I'm going to parse the JSON. So data is going to be JSON.load, and this is going to be a JSON request. So I'm going to parse the JSON. So data is going to be JSON.load, and this is going to be JSON.load. And this is going to be a JSON request. So data is going to be JSON.load. And this is going to be JSON.load. and it's going to be request. Next up, we are going to extract the text that needs to be translated. So data.get, it should be inside the text field. Next is dest. So dest is going to be the language we want the text to be translated to. So what I'm going to do is this data.get dest, and by default nothing is provided. I'm just going to translate English. So let's get equals to translator. So translated is going to be translator dot translate all, of course. So translate text we want to translate, destination, like what language we want to change it to, and source is going to be auto. It is going to auto detect what language we are passing as the text here. So the only thing that remains is to return the response. So it's going to be JSONify, and translation going to be translated.text, and source is going to be translated.source, and received is going to be the text that we received. So this is the response we want to send. So yeah, our function is ready here as well. Again, back to pydict.yaml, use localhost 5000 here again. And this template now not only holds pydict function but translator function as well. So giving it a generic name actually makes sense. So let me do that. I'm going to do mb pydict.yaml to function.yaml. So it's functions.yaml now. Changes will be reflected here as well. So now the only thing that I need to do is upload it or deploy it, and that can be done using a single command, that is faas CLI deploy -f functions.yaml, and I'm going to filter it out to just deploy the translator function, because we already have dictionary function deployed. It's not deploy, it's up to do build, push, and deploy a single command. So yep, going to build the image, then it is going to push it to our local Docker registry, and it is going to deploy it to our OpenFaas. Anytime now. All right, our image is getting pushed to the registry, and it is done. Now I do Docker images, so it's going to have a translator image which was built 11 seconds ago, and now I can go to my faas CLI store, and we have this translator function here. So what I am going to do here is text. We need to send a JSON file, and I'm going to do namaste here, which is a Nepali word for greeting someone, and the destination is going to be, let's say in this case, Arabic maybe. All right, let's see what is the response. All right, so this is a JSON, so I need to select JSON here, invoke. Okay, internal server error. Okay, there seems to be an error here. So I think what the mistake is, okay, this should be s, because we are loading string and not a file. So again, back to my terminal and faas CLI up. Do this one more time. So it's going to be pretty quick, because like Docker has cached all the images and things like that. So it should be faster than before. All right, it's done. Now back to our browser. Now let me run this command one more time. And now, yep, we have the translated text for the word namaste. And if I want to do this for Korean, I can do ko, and it returns Korean. And for other languages like Dutch, so nl, going to return hello. So it's basically namaste means hello in Nepali. So yeah, that's pretty cool. And if you want to know the list of supported languages, you can go to the official page, documentation page for Google Trans in PyPy, and you'll find it there. Now that we have our functions deployed, the next thing I want to show you is the metrics server using Prometheus. So OpenFaas deploys it when we are installing OpenFaas to the Kubernetes cluster. So if I do kubectl git pods and inside of OpenFaas, okay, git pods minus n OpenFaas, so we can see we have Prometheus here, and let's see the service as well. So yep, it's running on port 9090. So we would also want to port forward it and use it on our browser. So to do that, what I'm going to do is kubectl port forward and OpenFaas gateway faas service and Prometheus and 9090 to right. Okay, a mistake again. All right. Now we are port forwarding Prometheus to our localhost port 9090. Let me go to the browser and go to localhost 90, and yep, we have this Prometheus UI in front of us, and we can get a bunch of things that we can test out. So let's say function invocation total execute, and it's going to show a graph of what kind of functions were triggered. Like we have PyDeck translator was triggered multiple times, so data like in 30 minutes, 10 minutes, and you get all these cool graphs. So that's pretty handy. So that's it for this tutorial, guys. I hope you had fun learning about OpenFaas, and if you want to learn more and get deeper into this ecosystem, you can go to the bottom of OpenFaas official page, and there is this workshop which is a walkthrough of different things you can do using OpenFaas. And you can join the Twitter community or the Slack community and ask your questions, showcase your projects and things like that. And if you are into open source, most of the tools are open source, so you can go to GitHub and contribute there as well. So that's it for this video. I'll be seeing you in the next one. If you like this video, give us a thumbs up. And if you have any queries or suggestions, leave them down in the comment section below. I'll see you next time.